Hello everyone, this is a walkthrough of the grid game framework only if you do not have IntelliJ, so you're going to do it entirely on repl.it. Head on over to repl.it /@ddobrovich/gridgametemplate, and it'll take a little while to load. This file you see displayed is the .repl.it file. You should never change anything in this file because this is what actually compiles and runs your program, and you don't want to break that. Instead, head on over to run textgame.java. You may remember that we talked about ModelViewController as a way of organizing larger programs. If you don't worry, because I'm going to tell you right now. The idea is that there are roughly 3 different kinds of tasks that your program needs to be able to handle in order to run. There's the model, which is all of the information that your program needs to manage. It's the data. For our particular games, that's going to be things like where are the pieces on the game board, how large is the game board, how many turns has each player made, who's winning, that kind of stuff. The view is all the code related to how things are going to display to a user, how things are going to look. And then the controller is the thing that actually controls the process of the game. But mostly that involves handling user interactions. So when the user clicks somewhere, the controller is what decides what's going to happen depending on where the click happened. So usually the controller class is the one that you would actually run. It's sort of like the main class. And then the controller interacts with the model and the view. A typical way of imagining how these classes interact with each other is the user will click on somewhere on the screen. The controller knows the XY coordinates where the user clicked. And so the controller might ask the view, do we know what actual grid location they clicked on based on those XY coordinates? And the view might tell the controller, yeah, they clicked in row 5, column 4. And then the controller might ask the model, hey model, do we know what game piece is located at row 5, column 4? And the model might say yes, and then the controller might tell the view to change something else. So that's the way the interaction happens. Usually the model and the view don't interact with each other directly. For our project, GameBoard.java is the model class. It's what represents the information about the current state of the game and includes all the logic about the rules of the game. Run TextGame is acting both as controller and as view. It acts as controller because it's the thing that handles the user interactions, but it's also acting as the view because it's controlling how the game board gets displayed here. Mostly you shouldn't need to edit anything inside this file. At the end of the video, I'll walk you through it so that you can kind of see how it works. But for you, everything interesting is going to be happening inside GameBoard. The variables at the top represent all the information that you need to remember about the current state of the game. So right now, that's only the 2-dimensional int array that represents what grid squares are actually active or not active. Later, if you want to make a 2-player game, you would need to have other information about the player's scores and other things up here. You might notice that here we've got a variable that could be holding a 2D int array, but we haven't actually made one yet. That happens here in the constructor. And the reason why is because here when we first define the game, we don't know how large we want the game board to be. That's something that we decide only from the controller. In the controller we say, please make us a game board that's 5 by 5, but if we wanted to, we could make a game board that was a different size, 5 by 10. And so those 2 inputs get sent here to the game board constructor, and they get used to actually make the new 2D int array. The only other things that you need inside the constructor are the other initializations that need to happen. So if your grid needs to start with certain values in it, you would initialize those here. The reason why the upper left-hand corner starts with a piece in it is because of this right here. In the next video, I'll show you how to make a couple of basic changes to this, but hopefully you can imagine how you would start the game in a different starting configuration by putting values in the grid. So move is the main method that is interesting to you. This method is run by the controller whenever anybody types in the row and column that they want to move in. The only thing it does right now is print this debugging info, and it says you clicked. You didn't actually click, but yeah, somebody typed a row and column. It's going to be up to you to do 2 things. First, you need to check to see if the row and the column are actually valid. If they typed a row and a column that are too big or too small, so they're outside the grid, then that's not a valid move. If they typed a row and a column where, let's say it's a two-player game and they're trying to move their opponent's piece, that wouldn't be valid either because it's against the rules of the game. So first you need to do all the checks to make sure that they're not trying to break any rules. As long as the move looks okay, then you would have code that actually changes the values inside the grid to reflect the move that's being requested. So for our game, Turn Off the Lights, if someone's trying to move in row call, what you're going to do is you're going to change the value at the location they requested, but then you're also going to change the values at the 4 neighboring locations, above and below and left and right, to turn on or off the lights. The isGameOver method will return true if the game is over or false otherwise, but you have to complete that method yourself. So in our game, Turn Off the Lights, the game is only over when all of the lights are off. And so what that means is all of the values in the grid are equal to 0, because that's what it means for the lights to be off. This getGrid method just returns the grid so that the view is able to display it. And then the last one is one that is optional, but is helpful to complete if you want. It's called isInGrid, and it takes a row and a column. And the purpose of this method is just to return true or false for whether or not this row and column is inside the grid. The reason that might be useful to you is because you can run it from up here and move. So the very first thing you might want to do before anything else is say if is in grid row call equals false. So if the move they're trying to make is not in the grid, then you could immediately return false. This exits the method, so any code down here that's going to try and put things in the grid won't run, because as soon as you hit the return statement, you've exited. False is the value that you should return if no move was made, to indicate that there was a problem with the request. So this is just a quick way of saying if they requested a move that's not in the grid, then exit immediately without moving. But, of course, it doesn't work by magic. You have to fill in how the isInGrid method actually works yourself. So that's it. If you want to start programming, you can go ahead. Otherwise, keep listening, and I'm going to do a quick walkthrough of how the controller class actually works. So the most important object that we have is the game object, which represents the GameBoard. These are all about the display and how we get user input for choosing the moves. So the first thing that we do is we make a new GameBoard with a particular width and height. And then this while loop is called a game loop. We're saying as long as the game isn't over, we're going to do a series of things. And what we're going to do is we're first going to display the GameBoard. Then we're going to ask the user where they want to move. And then we're going to handle the move. So let's look at each one of these parts in turn. Let's start with display board. Display board is defined down here somewhere. Here it is, display board. So display board takes the 2D grid as an input and also a Boolean for whether or not we actually want to display the row and column numbers on the outside. So if we do want to display the row and column numbers on the outside, then I have a loop which will first display that top row of the column numbers. Then we're going to loop over every row. If we're displaying the row numbers, we're going to display the row number we're on right now on the left, and that's why we have a print statement instead of print line, so that we don't go to the next line after displaying the row number. And then we loop through all of the columns in our row. We get the value out of the grid, and then I get how we want to display the grid value. So I get the display string. The display string is just the symbol that we're going to use for a particular int value that we see in the grid. And you can change that here. So we're saying if the grid value is empty, display a dot. If the grid value is 1, we'll display an X. If it's 0, oh, we display a 0. That's weird. Let's do that. So you can change what symbol you use there. And then once we've gotten the display symbol, then we actually print out the display symbol plus a spacer. And the spacer is defined at the top, and I think it's just, yeah, a space right now. But that's so that the display of your grid is a little bit more spaced out. So that's display board. Let's go back up here to the game loop. So again, while the game isn't over, the first thing we do is display the board, then we get the user move. Let's look at that. So get user move is defined here, and we just have a prompt where we say type the row and the column. Then we ask the keyboard, which was a scanner that we declared at the top, for the next line, and then we just return whatever it was that the user typed. So that's it. But after the user typed something, we actually have to be able to handle it. We have to interpret what are they trying to do. So the first thing I say is if the thing they typed was quit or exit, then we'll go ahead and display that we're quitting and we'll exit the program. Otherwise, I want to convert the string that the user typed into an actual location object that stores the row and the column. So let's look at how this works. The first thing I do is run a method called trim, which removes any spaces at the beginning or end of the string. Then I have to parse the string. What parsing it means is breaking it into parts and interpreting the meaning of each of the parts. So here I'm asking if the string contains a comma, then I want to break the string into pieces, the piece that happens before the comma and after the comma. Or if their string contains a space, then I want to do the same thing. I want to break the string into what happens before the space and what happens after the space. The way I do that is a method called split. What split does is it turns your string into an array, and each array value is determined by the part of the string that happens before this splitting value or after this splitting value. So I want to make sure that after I've split it, I actually have some values and that I have at least two values because I want to make sure there's a row and a column. If I don't see that, then I'm going to display an error which tells the user that they didn't type it correctly and gives them some hints about how to type it correctly. Otherwise, what I'm going to do is I'm going to take the first element in my array, which I'm hoping is the row number, and I'm going to take the second element in my array, which is the column number, and I'm going to parse those as ints. And that creates a row and a column. And then I'm going to create a new object that's a location object from that row and column, and I'm going to return it. Otherwise, if something goes wrong inside here, this is called a try-catch block. It automatically catches certain kinds of errors. So if something goes wrong in here, instead of crashing, it'll run this code inside the catch part. And again, it will display an error and said that something is wrong in how you typed it, and we return null as a way of indicating that the move wasn't valid. So let's go back to the game loop. So we had the user type in whatever move they wanted to make. If they typed quit, we were going to exit. Here, the result of this is that we tried to convert their string into an actual location object. Remember that if something goes wrong, we return null. So the first thing I do here is I check to make sure that the location is not null. If it is null, this if statement is false, and so nothing runs, and we go back to the top of the game loop, and everything happens over again. If the location isn't null, that must mean there is a valid location object, and so I tell the game to make a move at the particular row and column that are inside the location object. And then the move method inside game returns true or false for whether or not we were able to make the move. We save that inside valid. Right now we're not doing anything with that, but if we wanted to make a more sophisticated interaction, we could test here and see if the move wasn't valid, then we could print some information to the user that tells them that their move was invalid and that they should try again. Okay, well, so I know this was a lot of code. I wasn't necessarily typing this with the idea that you would be modifying it, but certainly this isn't super bad for people going into AP. So if you are thinking about taking AP next year, definitely try and understand how this is organized and play around with it a little bit. I think it illustrates some good coding practices.